Welcome to this video, dear learners. In this video, we're going to look at atomic structure. So we looked at atoms in our previous videos. We looked at atoms, elements, compounds, molecules. So if you haven't watched those videos, please kindly watch the videos on the channel. So for those new to the channel, please hit the subscribe button, like, share, and leave a comment. Okay, so atomic structure. Here we are simply looking at the structure of an atom. Okay, before we dive into the structure of an atom, let's first just remind ourselves what an atom is. So an atom is the smallest particle of an element that can take part in a chemical reaction. The smallest particle of an element that can take part in a chemical reaction. Okay, so we said the atom is the smallest particle, but through discoveries and scientists discovered that even though the atom is the smallest particle of an element, it has what we call subatomic particles. Okay, we call these subatomic particles. Subatomic particles. So the atom itself is also made up of very, very small particles that we call subatomic particles. Okay, subatomic particles. So subatomic particles, these are particles found within the structure of an atom. Okay, or they make up the structure of an atom. So we have the structure of an atom here. Okay, so as you can see the drawing there, you have a ring. Okay, this ring simply denotes what we call the shell. Okay, this ring simply denotes what we call the shell, and in this shell it is where you can find one of the subatomic particles that we call electrons. So these electrons simply revolve around this ring, or what we call the shell. Okay, or in other words, the shell is also called an energy level. So they are also called energy levels. So an atom will have more than, depending on the type of atom, it can have more than one shell. Okay, if it's hydrogen, it will only have one shell. Okay, so it depends on the type of atom. Other atoms have more than one shell. Okay, so all atoms are made up of rings, okay, or shells, and in those rings, that is where you find subatomic particles that we call electrons. Okay, we call them what? Electrons. And these electrons, they revolve around this shell, similar to how planets revolve around the sun. Okay, so now at the central part of the atom, the central part here, you have what we call the nucleus. Okay, you have what we call the nucleus, and inside this nucleus you find the two other types of subatomic particles, and these are the protons. Okay, you have the protons as well as the neutrons. Okay, the protons as well as the neutrons. Okay, so how many subatomic particles have we talked about? So we have one, the neutron. Okay, two, the proton, three, the electron. So these are the three subatomic particles. So the neutrons and the protons are found inside this nucleus. Okay, the ones shown in green are the neutrons, and the ones shown in black are the protons. Okay, so these are not their colors, I just drew them like that for easy illustration. Okay, so the electrons, as you can see, they're around the shell of this atom. Okay, so now let's look at the characteristic of these particles. Okay, so we said we have three particles. So number one, you have the protons. Okay, two, the neutrons, and three, you have the what? The electrons. Okay, so a proton simply has a mass number of 1. Okay, so this is the mass. The mass of a proton is 1, Okay, we are using AMUs. Okay, these are the units. Okay, AMU. Okay, so it's 1 AMU. The neutron also 1 AMU. But the electron, it has a very, very small mass, and we call this mass negligible mass because it's insignificant, because if you were to divide this number, you're going to get 0.00. Okay, so the electron has got a negligible mass. Okay, a negligible mass. Okay, it has a negligible mass. Okay, so apart from knowing the masses of these subatomic particles, you also need to know the charge. So the proton has got a positive charge, okay, +1. The neutron, the name itself, neutron, it was named neutron from the word neutral, okay, neutral. This is simply because the neutron doesn't have any charge. It is neutral. Okay, it is simply neutral, no charge at all. Okay, but the electrons, the ones on the shells, okay, these are negatively charged. Okay, so this is negative charge of -1, and then this is positive charge, okay, +1. Okay, so now if we were to look at what is the total charge, okay, what is the total charge of the atom? Okay, so the total charge of an atom, the total charge, if we were to add all these charges, so you have 1, okay, plus you add the charge there 0, okay, plus you add the charge here -1, okay, you end up getting what? 1 minus 1, and you get 0. Okay, so what does 0 mean in terms of charges? Simply means that the atom itself is neutral, what we call electrically, it is electrically neutral. Okay, the atom is electrically neutral. Okay, and this is because the number of protons is equal to the number of electrons. Okay, the number of protons is equal to the number of what? Electrons. Okay, so if you have, let's say, 11 protons, okay, this means that you also have 11 electrons. 11 protons is equal to 11 electrons. Okay, so now if you were to add, okay, 11 protons simply means that you've got 11, you have 11 positive charges, so plus, you add plus -11, okay, for the electrons, you simply get 11 minus 11 charges equal to 0. That's why we're saying that an atom is electrically what? Neutral, and the total number of protons is equal to the total number of what? Of electrons. Okay, is equal to the total number of what? Electrons. Okay, so now let's look at what we call a nuclide. Okay, let's look at what we call a nuclide. Okay, just a few minutes. So a nuclide is simply it consists of a symbol. Okay, so a nuclide has a symbol like that with A on top and Z down. So to call a nuclide, the A here simply represents the mass number, and the Z simply represents the proton number. Now, since we've said proton number is equal to electron number, it also indicates the electron number. Okay, electron number. Now, what is this mass number that we are talking about? Okay, what is the mass number? mass number, which is denoted by what? A. Okay, mass number is simply equal to number of protons plus number of neutrons. The mass number simply equals to the number of protons and the neutrons. So when you add, okay, remember the protons and the neutrons are both found where? At the center, okay, which is here, okay. So this is where you'll find the mass number, okay, because you add the number of protons and neutrons, okay, the mass of the proton and the mass of the neutrons, you get the mass number, okay. So mass number is simply equal to what? Protons plus neutrons, okay. We can write it as mass number A is equal to protons plus neutrons, okay, and then Z simply equal to protons, okay, which is also equal to electrons, since we said protons and electrons have the same number, okay. So let's give an example, okay. So let's say you have an example here. Now this nuclei, you don't need to memorize them because these are there on the periodic table. So when you go on the periodic table here, let's say you're looking at calcium, which is a group 2 alkaline earth metal. So you're going to find calcium written like this on the periodic table with a 20 down, okay, and a 40 on top, okay. So that is how calcium is, okay. So this 20, I mean the 40 up, it is your mass number, which is denoted by A, and the 20 which is down here is the proton number, denoted by what? By Z, okay. So if I ask you what is the mass number of calcium, go on the periodic table and look at the number on top, okay. That is how you do it, okay. So here if I ask you how many protons are in this calcium, okay, you are going to say Z is equal to protons. Z is equal to protons, which are 20, they're 20, okay. These are the protons. If I ask you how many electrons are here, okay, so you're going to say electrons are simply equal to protons in number, and they are 20 as well, okay. The number of electrons is called the number of protons, okay. What about neutrons? Okay, so for neutrons, remember we said mass number is equal to protons plus neutrons, okay. And what is the mass number here? It is what? 40. So you just write 40 here is equal to, what are the number of protons? 20 plus n, and you can calculate n, okay. You simply move the 20 this side. This is 40 minus 20 is equal to n, and n is simply 20 as well, so meaning the neutrons are 20, okay. So the neutrons are also at 20, okay. So looking at this is the mass number. You find it on the periodic table, okay. This is the mass number, this is the proton number, okay. Proton number, the proton number is also equal to the electron number. So proton number, it is also known as the atomic number. That is the other name, okay. Mass number is also called the nucleon. So just the other terminologies, nucleon number. So I can say, what's the nucleon number? I simply mean the mass number, which is the 40. What is the proton number? It is the one down, which is the 20. What is the atomic number? Atomic number and proton number are simply the same thing, simply the same thing. Okay, so now that we've learned about this, I want you to go on your periodic tables and just remind yourself of different types of elements on the periodic table. So the number on top is the mass number, the number down is the proton number. Okay, so let's have let's look at something else. Okay, so arrangement of electrons in an atom. Okay, so if you look at this, so you have this element called sodium. So in the periodic table, you find that sodium is written as Na, and it has 11 down and 23 on top. So from what we are explaining, 23 is the mass number, which is A, and 11 is the proton number, which is Z. And for you to get the number of neutrons, you simply subtract A minus Z. A minus what? Z, okay? And what is your A? 23. Your Z is 11, and you get 12 as the number of what? Electrons, okay? As the number of what? Electrons. Okay, so now the arrangement of it, let's look at how is this arrangement. How are the electrons arranged, okay? Because just by looking at this 11 down, already I know that the number of electrons in sodium are also 11, okay? Because the Z number is equal to the proton number, and it is also the electron number. So there are 11 electrons here. Now, how are these 11 electrons arranged in this atom? Okay, that's what we want to look at. Okay, so we're saying that electrons lie along rings or shells or energy levels. And these energy levels are assigned letters K, L, and M. So this is the first shell, okay? Shell number 1, it is denoted as shell K. Shell number 2 is noted at shell L. Shell number 3 is denoted at shell M. So it can go on. If you have shell number 4 here, it will be noted as what? N. Okay. The next one will be O, P, and just like that alphabetically. Okay. But they start on K. So this is the formula we use to find out how many electrons can occupy the first shell. Okay. How many electrons can occupy the first shell? Okay. So the first shell is 1. Okay. This means that so this is our N number. Okay. This is our N. Okay. So here in the first shell you have 1, shell number 1. So to find the number of electrons, you simply use this formula. You say 2n squared. So if you put 2 there, your n is 1 squared. You simply get 2. So meaning that the first shell will only consist of 2 electrons. Okay. So the maximum number of electrons that can occupy the first shell is simply 2. Okay. It is simply 2. You go to the second one, shell number 2 assigned by the letter L. So you put 2, meaning your n here is 2, and then squared. So if you do 2 squared, it is 4. So here you get 2, and then there are 4. 2 squared is 4. 2 times 4, you get 8. So meaning the second shell can occupy up to 8 electrons. Okay, 8 electrons. The third shell, so you get 2 here, your n is 3, and then squared. Okay, so this is 2, 3 squared, that is 9. 2 times 9, you get what? 18. This means that the shell number 3 can occupy up to 18 electrons. Okay, it can occupy up to, so this is the maximum number of electrons. Okay, so the shell number 3 can occupy up to 18 electrons. Shell number 2 can occupy up to 8 electrons. Shell number 2 can occupy, the maximum it can occupy is 2 electrons. Okay, so now let's look at what we call the electronic configuration diagram, and we have sodium as an example. Okay, so you have sodium there as an example. Okay, so these are the number of electrons. Remember, the protons, we say here the protons are 11. Okay, what are the electrons? The electrons are also 11. Remember, the number of protons is what the number of electrons. So you have 11 electrons here. So let's look at what we call the configuration diagram. Okay, So these 11 electrons, how are they going to occupy the shells? So you're going to start, okay, here we've learned that shell number 1 can occupy how many electrons? 2. That's the maximum. Okay, so you're going to say, okay, shell number 1 can occupy 2 electrons. Okay, then what about shell number 2? Okay, shell number 2 can occupy 8 electrons. So shell number 2 occupy 8 electrons. Now if you add shell number 1 2, shell number 2 8, what's your total here? You already have 10. Okay, the total here is already what? 10. But the number of electrons in sodium is only 11. Okay, so the third shell, meaning it will simply occupy, what's the remainder? If you add 2 plus 8, you get 10. 11 minus 10, you have 1. So meaning the third shell will only have 1 electron, because the electrons are finished. So out of 11, 2 will go in the first shell, then 8 will go in the second shell. So 2 plus 8, you have 10. You're only remaining with 1 electron, which will go in the third shell. Okay, and this is how you show them. So you're going to say, okay, this is my nucleus of sodium. Okay, so the first shell is simply going to have 2 electrons. You write the electrons. Okay, 2 electrons. Then the next shell is simply going to have 8. So you pair them. Electrons can be paired. Okay, 2, 4, 6, 8. So there are 8 electrons in this shell. So this is shell number 1. This is shell number 2. But shell number 3, only 1 electron. Okay, so this is how the electrons are going to be arranged. Okay, this is how the electrons are going to be arranged for sodium. Okay, this is how the electrons are arranged for what? For sodium. Okay, let's look at another example. Okay, so let's try to come up with the electronic configuration for calcium. Electronic configuration for calcium. So this is your mass number A, this is your proton number Z. So you have 20 protons. This means that you also have 20 electrons. Okay, if I wanted to find the number of neutrons, I'll simply do 40 minus 20. Okay, you always subtract this, you still get what? 20. So even the number of neutrons are simply what? 20. Okay, but here we're interested in, I want to see how these electrons are arranged. Okay, so we've already said here, shell number 1, okay, shell number 1 can occupy 2 electrons maximum, but then we have 20 electrons. Okay, so we're going to start. Shell number 1 can occupy only 2 electrons, so 2 electrons in shell number 1. Shell number, so now remember 2 electrons, so we're remaining with how many here? 18. Okay, but we are told this second shell, shell number 2, the maximum number of electrons it can occupy are 8. So we're going to write it can occupy 8. Okay, so now if you subtract now, okay, so 2 plus 8, you get what? 10. You subtract from 20, you have 10 more electrons remaining. Okay, 10 more electrons remaining. Okay, 10 more electrons. So the third shell can occupy up to 18. Okay, so let's say we put 8 again here. Okay, so you have what? 18. 18 minus 20, or 20 minus 18, meaning you're going to have the fourth shell. Okay, it's going to have 2 more electrons. 2 more electrons. So first shell occupy 2, second shell 8, third shell 8, the last shell will have 4, but the total should give you 20 since there are 20 electrons. There are 20 electrons. So let us see how we can draw this. Okay, so you are simply going to write okay, so you have the electronic configuration is 2 8 8 2. Okay, that's how we're going to do this. Okay, so we're going to write the nucleus, write the symbol for the element calcium. So shell number 1, 2 electrons. Shell number 2, 8. So pair them 1. So this is 2, 4, 6, 8. Okay. Shell number 3, you pair them again 2, 4, 6, 8. Shell number 4, only 2 electrons. 2 electrons, those that were remaining. Okay, only 2 electrons, those that are remaining. Okay, so here you should always avoid to, always try to avoid to write more than 8 electrons in a shell. Okay, always try to avoid writing more than 8 electrons in a what? In a shell. Okay, let's look at one more last example. So let's look at chlorine. Okay, so chlorine, you'll find it on the periodic table written as 17. Okay, the mass number is 35.5. Okay, 35.5. So the number of protons, so it has 17 protons, meaning it also has 17 electrons. Okay, let's do the electronic configuration structure. So the first shell, we know it will occupy 2 electrons. Okay, 17 minus 2, that is what? 15. So the second shell will occupy 8. Okay, so 10 minus 17, you have a remainder what? 7. And this is the electronic configuration. So shell number 1 will occupy 2 electrons, shell number 2 occupy 8, and shell number 3 will occupy what? 7. Okay, so we write the nucleus with the symbol for chlorine. So first shell, okay, 2 electrons. Second shell, 8 electrons. Always pair them. Shell number 7, shell number 3, 7 electrons. We pair these 2, 4, 6, and 1 remaining here. Okay, and this is the electronic configuration diagram of chlorine. Okay, so we've looked at quite a lot. Feel free to pause the video at any time, also to replay the video where you're not clear, or if you have a question, please leave it on the comment section. Okay, so what we've covered here so far, we've looked at the atomic structure, for the structure, the characteristics of these subatomic particles, and then we've also looked at the arrangement of electrons in an atom.